Okay, so this is the setup for the Swinging with Bob lab. So this is just the overall setup. You're using two sensors, a force sensor and a Photogate at the bottom. So let me kind of walk through, zoom in on what you're going to do physically, and then we'll look at software. So your force sensor is up here at the top, and in the Swinging with Bob equipment, you have like a little wood block, and you are going to put that like right in the middle of the force sensor there. Sorry, this is a little hard, it's on a stool. And you'll see, you will then clamp it to the table. So the wood block is going to essentially go into the force sensor, and you will then use that little black screw to screw it down. And then you will take that block and actually clamp it to your table, okay? And then I have my protractor, and it's going to be measuring my angles. So let me kind of zoom in on that. So I have actually taped a piece of paper right to the back of it. And the reason is partly because my table is dark, it was hard to see, but also I wanted to be able to write down some angle measurements. So it's just easier for me when I'm lining it up to know where my string is. So you're going to be using two angles, 10 degrees and 20 degrees, and that's from the vertical. So like right now, the string is hanging completely straight down. And when I swing it or I kind of move it, this angle here is the 10 degrees. So that's why I've kind of put the 10 degree and 20 degree marks there. Okay, now the next thing you need to set up is your Photogate. So your Photogate is just going to get set up in the Photogate stand of science. And we've worked with this before. It's just going to kind of slide onto there. Now, kind of in terms of where you're going to position it, depends on your string and your bob. So this is the pendulum bob. And let me zoom out just a little bit. So your pendulum bob looks a little different, I think, than mine for most of you. And what you want is you want the Photogate to be at the direct bottom of your pendulum, okay? So you're gonna allow it to kind of hang. Mine's kind of spinning like crazy. And you want this to be in the very, very direct bottom. So you're gonna need to move this around so that this is at the very, very direct bottom, okay? You also want this to be in the middle such that when you allow it to swing, you've got a little bit of freedom in that it's not gonna like hit one of these. You do have to be careful. You've got more wires than you're used to because for your sparkling air, you're gonna have your force sensor and your Photogate. So remember, your Photogate attaches to the digital adapter. The digital adapter attaches to sparkling air. Please remember to turn it on. We haven't used this in a while, so just reminding you guys, there's an on button. I've hardwired mine into my computer, so I've got a solid green light. If you are using the Bluetooth, you'll get a solid blue light. So make sure your kind of wires are out of the way and they're not gonna like impede the movement, meaning like you don't want your pendulum to like hit the wire from your force sensor, okay? Okay, so let me kind of zoom out. I'm gonna take this off because I need to calibrate my force sensor. And let me zoom out and then we'll kind of go through the software. Okay, so you get the opening screen from SparkView, and the first thing you're going to want to do is just select sensor data. And it innately recognizes the force sensor. We do want to be mindful and select force pull positive as our option because we're pulling down on the force sensor. And then for our digital adapter, notice that there's nothing there to select because we have to set up our digital adapter. So I'm going to go ahead and select this little cog here, configure sensor, and I have to assign it. So I have one Photogate, so I'm going to select that option, one Photogate, and I'm using it for timing. So I've got this Photogate timing option right here. Okay. And then reminder, when you're using a Photogate, you actually have to plug in the diameter of what's passing to the Photogate. So for us, this is like the width of our pendulum bob. So just going to take your ruler, measure out the diameter of this. Yours will be different than mine is. Mine was 2.8 centimeters, but again, you'll have to measure your own. Select OK. And now you get some options for your Photogate. So you have these options here now. We want to know what the velocity is in the gate. So I'm going to select velocity and unselect time. And then in regards to your template, we're going to go ahead and select table and graph. We don't necessarily need the graph, but they're just kind of together. So now you have a table that is going to display some values. the first thing we need to do is zero our force sensor. So with nothing hanging on your force sensor, you're going to press start, allow it to run, hit the 0 button, make sure that it's calibrated, good to go. And you can delete that run or just hide it, it's up to you. The next thing we need to do is we need to mass how much this thing is. So we need to weigh this object. So go ahead and you can do it one of two ways. I think maybe the easiest is just to put it on the hook, and let it hang freely. And press start, stop. So mine just says 2.0. Let's go ahead and increase the precision of that. So reminder how to do that. We're going to select the experiment tools, and we're going to select data properties. We need to select measurement, and we want to select the force pull positive. And then we're going to select number format. And right now it's only giving us 1 digit. We want to go ahead and increase that to 3. Select OK. And you should see a pretty clean value for what the weight of your object is. Now reminder, that's the weight in newtons. That is not the mass, that is the weight. So you'll want to record that value. Both you'll need to know what the weight is, and then you will also need to know what the mass is in terms, or when you do your calculations, okay? So that's the weight. Now we're gonna go ahead and run our experiment. So for our experiment, our goal is we're gonna run 2 different, I'll call it experiments, and then I'm gonna do some trials at 10 degrees, and then I'm gonna do some trials at 20 degrees, okay? One thing I found with my system is that when especially for the bigger angle, when I let it swing freely, my force sensor actually wobbles. And so I found that I have to kind of be careful. I've got to like start my program, and then when I go to release it, I have to hold my force sensor in place because I don't want it to wobble as much. So you may have to do that, okay? So in terms of what you're going to do, make sure that's set up right. You're going to release it from that 10 degrees, let it go, record the data. 1 time is fine. Release it from that 10 degrees, record the data, release it from that 10 degrees, record the data. So you're going to do 3 runs for 10 degrees, and then you're going to do 3 runs for 20 degrees, okay? So 2 experiments in the sense that one is going to be 10 degrees, one's going to be 20 degrees, but you're going to do 3 trials to average your data, okay? So let me run through one trial, and then I'll show you how to collect your data from the software. So I'm going to go ahead, and for me, it kind of helped to line it up with my 10 degrees first. You may have to press start first. Anyway, I'm going to press start. I'll hold my force sensor, line it up again. Like, oh, that was not a very good release. I'm going to try that again. Okay. Maybe it'll be better if I hold it with my right hand. Okay, press start. Line it up. Let go. Okay. So I let it swing through a couple times. I'm only going to collect the first data though. Something interesting to note, look at the sinusoidal nature of the force graph here. In that my forces are increasing, decreasing, increasing, decreasing. Okay, coming back to your data. So if you look at your data, you don't have a lot of velocity data, right? But you have force data, and that's because the force data is being collected 20 times every second. So we have to figure out where our velocity data is. We're going to scroll down, scroll down, scroll down, find it. There it is. Okay, 0.96. So that's my velocity. I'm going to record that velocity. And notice I don't have a force value at that exact time. Like my velocity was recorded at 5.087 seconds, and I don't have a force value. And that's because your force is just being measured like once every 20 seconds. And so it's just, it may catch it at that particular velocity time, maybe a little bit before or after. So what you're going to need to do is you're going to kind of need to just use some logic and say, okay, 5.087. The one previous was 5.05. The one after was 5.1. which of these two is closer in time? Which of these two is closer in time? And this 5.1 is actually closer in time to this 5.087. So I'm going to record this 2.339 value, okay? So I'm going to record these two values here, this 2.39 and this 0.96. So that's my force, my velocity, okay? I'm going to do it again. Line it up with the 10 degrees, let it go. That was a little bit better in terms of only letting it swing once. And here is my velocity value, 0.9. It happened at 6.612. So again, I'm looking, is 6.6 closer to that time value, or is 6.65 closer to that time value? And you should think, okay, 6.6 is closer in time, so I'm going to record this 2.248 and then 0.9. And then you'll do the run one more time so that you get 3 different values. Well, hopefully they're the same. They're very similar values for the 10 degrees. And then you'll get 3 values for the 20 degrees. And then you'll average those values, okay? So that's how you collect the data for this experiment.